All right, so I got a rectangle. I'm going to rotate it around W. W stays where it is. I'm going to rotate the rectangle around it. What type of solid do I end up with? Okay, so I'm rotating W. I'm rotating the rectangle around W. What type of solid do I end up with? Again, not too bad, right? Right off the bat. Usually, sometimes that's like a question 1 or 2 to get your feet wet. 23, what type of figure do I have? That's a cylinder, yep. The only worry I have, everyone sees rectangle, so they pick rectangular prism, but no. Hey. I'm going to rotate it around the side. Rotate it. We see the cylinder start to form. All right, let's roll 2. Now I'm taking a triangle, and rotating around AB. So think about the 3-dimensional figures we had. Which one does this one create? 11.
Cone.
That's a cone, yep. Not a pyramid, cone. Because I rotate that bottom, BC starts forming a circle. 3, I know it's kind of a repeat of 2, but I picked it and put it on here because of a vocabulary term I wanted to review with you. And it's not equilateral. We should know what that is by now. Median. What's a median again in a triangle? Median. You got 3 of them. Every triangle has 3 of them. They all intersect at the same spot called the centroid, but that's not what I'm looking for. What is a median here? Everyone take it, John?
It's a line drawn from a vertice to the opposite midpoint.
Good. Starts at a vertice, that's why there's 3 of them, and goes to the opposite side's midpoint. All right, yes. Even though you don't need to know what a median is here, but I'm revolving around it now. So what shape do I end up with? 26? Cone, yep, I end up with the cone again. I just want to make sure we reviewed median. All good. Oh, something else new as well during our review here. Now, if Promethean Man comes up, we get all excited, right? Oh, boy. But I'm not checking homework anymore. All right, so why bother canceling it? So instead, if you can guess the next slide or you get double Promethean Man, I'm going to give away something random in the room to somebody from the number generator. All right, so just to spice it up a little bit. All right, I have no idea. I have nothing in my head right now, but I'll find something to give away. That's pretty random, good or bad. And we'll pick a number off the generator, and that person will get it. All right, but that's only if you get double Promethean Man or guess the next slide. Yes?
Can we also do that for, same number, same answer?
Sure. What the heck? I got a lot of stuff I got to get out of here. All right, before the end of the year. So, all right, all good? Boom. All right, here we go. Ooh, big timer here. Slopes. First, let's take a few notes here. All right, so we don't forget about this. Parallel lines have blank slopes. Can we fill in the blank correctly? So 2 lines. How about two lines. There we go. 2 parallel lines have blanks as their slopes. Remember that one? Anybody taking that one? Have, Sky? Equivalent, equal, same slopes. 2 lines are parallel. You can guarantee their slopes are equal. The other type of lines we dealt with are perpendicular lines. Have blank for slopes. I probably did not make that blank long enough. There's a hint. And get specific here for me. I do not like the word opposite because it's more than that. All right, opposite to me means you just change the signs, but it's more than that. It's more than that. Bridger?
Negative reciprocal.
Thank you. You not only change the sign, but you got to flip that bad boy. Hence reciprocal. So have negative reciprocals. All right, so let's see if we can answer these questions, these multiple choice questions. Slope of line L, negative 1/3. What about a line perpendicular to it? And also, any problem we do is from an old Regents. All right, these problems are from old Regents exams to give you guys a little taste of the difficulty sometimes. All right, so I got slope of negative 1/3. So what should be the slope? What slope am I looking for now? That's perpendicular to it. What number am I looking for? 17? Negative reciprocal of negative 1/3. Positive 3. Now, here's the thing. This drove me nuts last period. You can't just look at choices 1 through 4 and find which one has a 3 next to the X. Oh, it's choice 4. No, it's not. You cannot determine slope until it's in y equals form. All right? So if I move, in choice number 4, if I move 3x over, what's the slope now? It's actually -3, so it's not choice 4. You have to get it into y equals form and then say, all right, which one has a slope of 3? So go ahead. Take a minute or two to do that. All right, what do you got for me? Did we find which one has a slope of 3? Oh, 11.
3.
Choice 3, yep. Okay. So one will come out to be minus the 9x and divide by -3. That's how you're going to get +3. Any issues? All right, so we understand slopes now. Next phase, next level up, can you write the equation of a line that's parallel or perpendicular? So I have this equation that's just nuts because it's not even in y equals form, not even close. I need a line that's parallel to this one and going through 1, 3. So right now, I'm going to treat this with you guys as it's not even, forget about multiple choice, this is even there. What if this was a part 2 or 3 question and you guys actually had to come up with the equation on your own instead of just having a 25% chance of getting it right? So let's pretend the multiple choices are not there, and how do I write the equation of this line? So here we go. What do we got? -2x plus 3y equals 4. First thing, what's the slope? So I can do the same slope because they're parallel. I have no idea. If you say -2, get out of here. Got to get it in y equals form. What's the first step to get that into y equals form? Oh, 18. Add 2x. Good start. So I get 3y equals 2x plus 4. Keep it rolling. Next step to get y by itself. 14. Divide by 3. All right, nice. So now I have y equals, what do I have there? 2/3 x plus, and I don't even care what this is, doesn't matter to me, but 4/3. I don't care what the y-intercept is there. All right, what's the slope of this line here? 20 slope?
2/3.
2/3. So that means because it's parallel, my new line, my answer should have a slope of 2/3. Only thing I'm missing, what the heck's the y-intercept, right? What?
Should that be a -4? -4/3?
It's -4.
Oh, it's a -4
Yeah.
up here? Sorry, thanks. Okay. So now I got to find the y-intercept. I at least know because the lines are parallel, my new line will have a slope of 2/3. What about the y-intercept? I go back to my good old equation, y equals mx plus b, and out of those 4 letters up there, which one represents y-intercept? The b. All right, so you got to give me something to plug in for y, m, and x then if I'm going to solve for b. Well, how do I do? We know the m already. That's 2/3. The slope has got to be 2/3 because they're parallel. How about the x and the y? Doom, doom, back up to the beginning of the problem. That's why they tell you it has to go through this point, 1, 3. There's your x and y. All right, so whatever point it goes through, that's what I'm plugging in for y and x and solving for b. So what do I have there? 3, 1. So 3 equals 2/3 times 1 plus b. And I don't feel bad because they're fractions because everyone's got a nice little fraction template on their calcs, which I will be bringing none extra. I'll be bringing no extra to the exam. So you have a month right now to prepare for that. Actually, 3 weeks, sorry. 7, what are we looking at here? 7/3? 7/3 for your y-intercept? All right, so if I did have to write this final answer on a part 2 or 3, show your work. Y equals 2/3 x plus 7/3 would be my nice answer in y equals form. And look, hey, I told you this is going to be a tough one. Just the test doesn't care you're in honors. Doesn't care one bit. Go back. Oh, unfortunately, none of my answers are in y equals. So I have to transform them into y equals and figure out which one is going to come out to be 2/3 x plus 7/3. Can we work smarter, not harder? Which 2 probably can I get rid of right away? I know the slope's not going to come out to be 2/3. Look, you start distributing right here, I get negative 3/2 x. It should be 2/3 x, right? Nope. And the same thing goes for 3. So now you got to work with 2 and 4 right now. I'll give you guys a minute. Work with 2 and 4, distribute, and move over the 3s. And which one comes out to be 7/3? Positive 7/3. Negative 7/3 isn't the y-intercept. Whew. It's not that funny. Nothing is. Nothing is. 13. 2. Choice 2. Good work. All right. So equation of lines. Big one. Big one. Oh, and you know every year it's going to come. Are you going to be ready? Partitions. Partitions. Let's review the steps on how to do a partition one. First thing, most of these partition questions say, hey, the use of the grid below is optional. For my honors geometry student or any student from mine, it's not optional. And I'll show you why at the end it is not optional. So use the graph and graph AB for me. All right, it is not optional for you guys. And big reason why at the end of this problem. If for some reason if the problem does not provide a graph, still no excuse. End of your packet on the Regents exam, you have your formula sheet and a sheet of scrap graph paper. All right. So even if they don't provide one and say it's optional, you got some in the back. All right. Where's point P? That partitions it into a ratio of 2 to 3. All right, let's go through the steps. If it's ratio 2 to 3, that means how many equal pieces should it be broken up into before I find point P? 5 congruent parts, 2 and 3 give you 5. So 5 congruent parts, yes, yes. All right, we're going to do some steps. We're going to do it to find the new x coordinate, and we're going to do those same exact steps to find the new y coordinate. So let's start here. X coordinate. Well, you said I'm breaking it up into 5 congruent. What am I breaking up, though? The distance you're breaking up. So everyone go on your x-axis or use the x coordinates of A and B. How far apart are they? So I can cut it up into 5 equal parts. So from A to B on the x-axis only, how far apart are the x coordinates? 14? How many? 10. I'm going to divide it into 5 equal parts. So what's that tell me? Every time you move 2 units on the x-axis, you break it up. But now here's the big question. I go 2 units. Do I stop? Is this point P? Do I keep going? Keep going? How many times do I need to go 2 units? The answer always is in the ratio. That's what that first number represents, 2. You're going to do that twice. All right? So I'm going to go 2 units. Take a look. I'm going to go 2 units twice. for a total of 4 units. That's how many moves I make on the x-axis. How many units I go. Total units. All right, you said go 4 total units, but from where? Your starting x coordinate. Where did you start on the x-axis? What's that number on the x-axis? 9? Where did I start on the x-axis? -6. So from -6, you better go over 4 units. And on the x-axis, I end up at -2. That's just your x-coordinate. Now we got to do the same process for the y's. Okay, here we go. Y-coordinate. How far apart are the y's now? Because they're not 10 apart anymore, like the x's were. How far apart are the y's? How far apart? 8.
5.
5 units. Again, cut it up into 5 equal parts. Now we're going to go 1 unit every time. But the question still remains, how many times do you have to go 1 unit? Back up to the ratio, and I can't stress this enough. First number only. I'm still doing this twice. I'm not going to fill your brain with what that next number means. It's something else. All right, so I always focus on the first number in the ratio. So we are going 1 unit 2 times again for a total of 2 total units from the start. And almost last question. Where did I start? On the y-axis, where did we start? 21, where did we start?
-5.
Yep, so from -5, you better go 2 units on the y-axis. So I should end up at -3. So if I am correct, point P should be -2, -3. Remember at the beginning I said graphing's not optional? Here's why. Easy check. That partition point better be on the line segment. If it's somewhere off, you know you did something wrong somewhere. So if I go to -2, 1, 2, down 3, 1, 2, oh, smack right on that line segment. And that's not even it either. All right, great, you got it on the line segment. What was my ratio again? What was the ratio? 2 to 3. So darn it, that 2 part better look shorter than the longer part of 3. All right? Easy. Now you're very confident you got. Not only did it land on the line segment, the left side of it is shorter than the right, and that's what it should have been, 2 to 3. Questions? Next one on your own, 7. See what you can do on your own now. Hopefully we're getting 2.5. We'll eventually finish. Keep going. There's no rush here. The problems I assign every night are just not random problems. It has to do with the topics we went over. I want to prove a point to you that, hey, I'm about to do 2 different exams and these topics are on both of them. Also, you may need something else. I'm not going to say this is all you need to answer the questions. You may, like I think one of the questions tonight, you're going to need a fact from the circle unit to help you out, but it still deals with parallel and perpendicular lines. All right, so you may need to look in your cold hard fact sheet for some help, but anything I assign that the night of deals with the problem, the topics we've already done in class. All right, you can get going, and you got to know if you're right or wrong. All right, so pull up the answer key. If all of a sudden you fly through these, no issues, and you got them all right, pick up your formulas you need to know. How many of those can you fill in? All right, I don't want to pack up early. We need everything we can here in the next 2 to 3 weeks.